All right, so I think I'm recording here. Let's take a look at this problem number 6. They give us two functions and they ask us to find the domain of the difference of these two functions, the quotient of these two functions, and the function composition. So the amazing thing is that we don't have to find the expression for these new functions. All we have to do is determine the domain of f and the domain of g and use those domains to find the domain for these new functions. So for the domain of f, well, the domain of any function is the set of all real numbers, excluding any values that cause division by 0. Well, I don't have any variables in a denominator, so I don't have to worry about that. But I do have a variable underneath the square root, and I can't take the square root of negative numbers, not within the set of real numbers. So the 6 minus 2x that I'm taking the square root of has to be 0 or positive. It has to represent a number that's greater than or equal to 0. So if I subtract 6 from both sides, if I divide by a negative number, I have to remember to change the direction of the arrow, and negative 6 divided by negative 2 is positive 3. So the domain for f is from negative infinity all the way up to 3, including 3. Yeah. What about the domain of f? Well, same idea. We don't have any variables in a denominator, so we don't have to worry about division by 0. And this 4x minus 16 has to represent a number that's 0 or positive. It can't represent a negative number because we can't take the square root of a negative number within the set of real numbers. If we add 16 to each side and divide by positive 4, we see that the domain for g has to be 4 or larger. All right. So let's come down here and think about finding the domain of the difference, f minus g. Well, to find its domain, we intersect the domain of f with the domain of g. So the domain of f minus g is going to equal the domain of f intersected with the domain of g. You have to be in both members to be in the intersection. Well, sometimes that's hard to see, so let's draw on a number line. The endpoints are 3 and 4. So I'm going to draw each domain on two separate number lines, but I'm going to include these endpoints 3 and 4 in my picture to help for comparison purposes. So for the domain of f, I'm less than or equal to 3. All of these numbers, it's in the shaded region. For the domain of g, I'm 4 or larger. So to be in the intersection, you have to be in both sets. But that's the empty set. There is no number that's less than or equal to 3, but at the same time greater than or equal to 4. So we say that this is the empty set. Maybe you've seen that symbol that looks like a 0 with a slash through it. We can't create a new function by subtracting these two functions. We'll never have any output for this. It'll be undefined. All right. What if we take the quotient? Well, to find the quotient, it's going to be the domain that we have in A plus any added restriction. We can't divide by 0, but since this is the empty set, when you intersect that with anything else, you have to be in both sets. So the domain of f over g is also the empty set because there's no way that we can add any restrictions to this. There is no values in there. So the domain for f divided by g is also the empty set. Now, what about this function composition? Let's think about how a function composition, g composed with f, how you build that function. You start with the second function, f. F receives its input, and the output of f becomes the input for g. That's why I think of this like an assembly line. So two things have to be true in order for us to have a pair, a point, on the graph of this new function. X has to be in the domain of f. Otherwise, that we don't have an output, the function, it would be undefined for that input. Second, the output of f has to be in the domain of g. So to be in the domain of f, we have to pick values of x that are less than or equal to 3. This negative infinity to positive 3. To be in the domain of g, the output of f, to be in the domain of g, has to be greater than or equal to 4. So let's see if we can solve this inequality. F of x we know to be the square root of 6 minus 2x. And I know that that on the left here, that's 0 or positive. So I believe that I can square both sides of this without running into any kind of contradiction or any kind of problems. You have to be careful about doing that, especially if in inequalities, if you multiply both sides by a negative value, you have to change the direction of the arrow. But I don't think that we'll run into that problem here. So if I square both sides of this equation, I get 6 minus 2x is greater than or equal to 16. I think I'm allowed to do that. I'll double check that after this video to make sure that I can do that. So now here, this becomes easy to solve for x now because I subtract 6 from both sides, and then I divide by a negative 2. So these have to be true at the same time. X has to be less than or equal to positive 3, and at the same time less than or equal to negative 5. Well, for those both to be true, x has to be less than or equal to negative 5. So I believe that the domain of g composed with f is from negative infinity to negative 5, including that endpoint. Let's look at f composed with g. Now, we start with the function g. The output of g becomes the input for f. So two things have to be true in this function composition. X has to be in the domain of g, and g of x has to be in the domain of f. So for g, we knew that x had to be greater than or equal to 4. If you're less than 4, you're taking the square root of a negative number. And this g of x, it's going to be in the domain of f, it has to be less than or equal to 3. So we know that g of x is the square root of 4x minus 16. But that's a positive value. I know that less than or equal to negative 3 might include negative values, but I know that right here, this is a positive amount. So I know I'm between 0 and 3 here. If I square both sides of this, 4x minus 16 is less than or equal to 9, and I think I'm allowed to do that. So now if I add 16 to both sides and divide by 4, what will I have? Well, if I add 16, and then if I divide by 4, so these have to be true at the same time. So for the domain of fog, I have to be greater than or equal to 4, and at the same time, be less than or equal to 25 over 4, which is a number that's a little bit bigger than 6, right? 6.25. All right. So, hey, I hope that helps, and I'll talk to you later. Bye.